Hi. So when you consider the periodic table, carbon is one of the versatile non-metal considered because it is able to form a varieties of compounds, and therefore you have a separate branch called organic chemistry. So let us consider some of the properties of carbon. Carbon is a 14 group element with their atomic number 6. So that when you write the electronic configuration, it is 2, 4. The first shell has 2 electrons present in it, whereas the valence shell has 4 electrons. What about their valency? So valency is actually the number of electrons lost or gained during the chemical reaction or when they are combining with some other elements. When you consider 14th group, as they have 4 electrons in the valence shell, it is expected that either they can lose the 4 electrons so that there is 2 in the inner core, which is now equivalent to the electronic configuration of helium, and again that can be stable, or else they are able to accept 4 more electrons so that then the configuration will be 2, 8. Again they are with noble gas electronic configuration. So they can have a valency of 4. Whether the 4 electrons are lost or gained is a question. Now let's consider the carbon is accepting the 4 electrons. So after accepting the 4 electrons, it is very difficult for the nucleus to accommodate all the 4 electrons because it is extremely small. Therefore, when you consider 4 electrons, accepting 4 electron is not possible in case of carbon as the size is extremely small, because the nucleus is incapable of accommodating that 4 electrons. What if they are losing the 4 electron and then they are having a charge plus 4? So in case if they are accepting the 4 electrons, there will be a negative charge. Then you are able to know the oxidation state or write oxidation state as -4. If they are losing the outermost 4 electrons, then there will be positive charge giving you +4 system. So if +4 is the oxidation state, or if they are losing the 4 electrons from the system, that indicate again it is difficult because removal of electrons requires energy. Removing the 4 electrons from this is very difficult because the nucleus tightly held all these 4 electrons, and again this is not possible due to high effective nuclear charge. Then what is the option for carbon? Carbon is not able to completely lose 4 electron or accept 4 electron. Therefore, the only possibility for carbon is to share their electrons, and hence the 4 electrons present in the valence shell of the carbon is shared during the chemical reaction or whenever they are forming the compounds, and hence carbon forms covalent compounds, and this is why carbon is able to form varieties of compounds. When you consider the property, one of the most important property of carbon is a self-linking property, and this is said as catenation. Due to the extreme small size and effective nuclear charge present in the carbon, they are able to link. So when you consider the individual carbons are able to link, and you are able to get varieties of carbons, compounds which combine with hydrogen, and this is said to be hydrocarbons. So when you consider the periodic table, generally all the p block elements are able to exhibit the property called catenation, self-linking property. That is even observed when you consider P4, where 4 phosphorus molecules are linked in tetrahedral manner, or when you consider sulfur, even in oxygen if you consider ozone, but the catenation property is observed to be maximum in carbon due to their extreme small size. When you consider the occurrence of carbon, carbon is able to occur either in the free state or in the combined state. In the free state, carbon is exhibiting, or they are present in the form of graphite, or you have diamond, and even fullerenes. If you are considering the combined form of carbon, you have so many compounds like carbon dioxide or glucose, C6H12O6 or sucrose, etc. So varieties of carbon compounds are present, and you have combined form of carbon. If you are considering the free state, graphite, diamond and fullerenes are the forms of carbon.